Hello everyone, welcome back to Sai Homeschool. Please like, share and subscribe my channel for more updates. So last class we studied chemical properties of non-metals and how the occurrence of ores, how we will obtain the ores. Metals did we get a pure form or not? Then those things we'll study in that metals, how they occur based on the reactivity series, low reactive elements, how it will be combined with how different forms of metals will be get from different ores means sulfide ores, carbonate ores, and oxide ores in the form of those things. Then how we will purify those things, how we will extract the metals, we'll see today. So we are getting the ores from the earth. So that is it pure? No. We already discussed in the last class. It is a more amount of mud, sand, particles it will be present. It will be dusty particles it will be present on the ore that we are getting on the earth crust. So that is large amount of these impurities such as soil and sand we'll call a ganj particles. This must be removed by to extract the metal. So before going to extract the metal, what we have to do is we have to first remove the ganj particles. That is ganj particles means impurities of soil and sand present in the ores. That is called ganj particles. So if we go to the how we will extract those metals, how we should clean. So whatever may be low reactivity, high reactivity or middle reactivity, moderate reactivity, all the metals should be first we have to do enrichment of these. So means you have to remove the ganj particles. That is the first step it will be involved. So how these physical properties and chemical properties of ganj and ore. So we are using a different techniques. So based on these, how they react with the process used to removing the ganj particles of ore based on the different physical and chemical properties means all the metals it should not be react in the same way so that it will and also all the metals obtained from the only one ore that is Zn ore what we studied last class different forms of ores we will get it no that we should by different physical and by using different physical and chemical properties we should remove these ganj particles. So that is extraction of first how we will extract the metals in the low activity series. So reactivity series what we have what we studied last class low reactive metals that metals how we will react from these ores. So low reactive metals it will be it is not react very much. It is little unreactive. So it is low reactive metals which will not react easily with the some other compounds in the nature. So the oxides of these metals can be reduced to metals by heating alone. That is, so we already studied last class what is roasting and that is how we will do this roasting and calcination in these extraction of metals. We'll see first step in this is first what we have to do enrichment of ore means that is first step whatever may be the reaction it will be involved that is concentration of ores. So what is the concentration of ores is here it is removal of sand and mud particles means remove of sand and mud particles is nothing but ganj particles. So remove of these sand and mud particles is the first step for all the reactivity series. So the mud and sand particles present on this ore, we have to remove that first. Then after removing these mud particles, so here if you take mercuric oxide, sorry, sulfide, it will be reacts with the oxygen, means in the presence of oxygen, you should heat the mercury sulfide. So you should convert the sulfide ores into oxide ores. So because sulfide ores, it is not easy to convert directly into the metals. We should not extract the metal from sulfide ores easily. So that first we have to convert sulfide ores into oxide also. So here what we are doing is, in the presence of oxygen, we have to heat the mercuric oxide. We will get a, sorry, mercuric sulfide we have to heat in the presence of oxygen. We will get mercuric oxides. So this you should heat in the presence of oxygen. So that is called, this process is roasting. That is, so in the presence of excess amount of oxygen, if we eat the ores, that is mercuric sulfide, if you heat in the presence of oxygen, you will get mercuric oxides. Then for this mercury oxide, if you heat, what will happen? You will get metal. So this metal is, it is not completely pure metal. Almost 90% of pure metal we will get it here by heating, by removing that mud particles and sulfide ores. Then it will be converted into oxide ores. If you use that oxide ores, you should heat, you will get a metal, that is. So this metal again you need to get to completely, you need to purify, you need to get pure metal. You should do refining. If you do refining, then we will get a pure form of metal. So here, second, another, so nature, it will be naturally, it will be obtained copper, it will be obtained in the form of copper sulfate. So in the sulfide ore form copper we are getting, again it will be reacts with the oxygen in the presence of heat. You have to heat in the presence of oxygen, you will get copper oxide. Same thing here we are doing. We have to convert sulfide ores into oxide ores. Then oxide ores you have to heat. So what we are doing here is, we are using again copper sulfate to remove the oxygen. So here what is happening here is, we need to use reducing agent to remove the oxygen. We are using only naturally what we are occurring the sulfide ores, those things we are using to reduce the oxygen here, so that it will be, reaction will be takes place within the reaction. We are not adding any external compound or external any reducing agents here to remove the oxygen. This is called auto reduction. So this is, as usual, we will call roasting. So what is roasting? Converted sulfide ores to oxide by heating in the presence of oxygen is called roasting. This is auto reduction. So what is happening here? We are not using any reducing agent from outside. Within the reaction, it will be, oxygen will be removed and it will be converted into the metal. So that this is called auto reduction. This is very important. Why we are using copper sulfate here to remove the oxygen? What is the role of here copper sulfate is? It is using as a reducing agent to reduce the oxygen from the copper oxide. That is, so low reactivity series. Then if you come to the middle reactivity series, what are the elements present in the reactivity series at the middle? So that we should read. Same thing what we have to do, whatever the metals we will get at the middle series is zinc, iron and lead, copper. These are moderately reactive elements. So this will be present in the nature in the form of sulfide and carbonate ores. So how we will obtain this? So we have to do here also, we have to convert that from into first oxide form. That is, first we have to do whatever the metals middle reactive, that you have to do the concentration of ores. So concentration of ores, again what we studied above, that is remove of Ganch particles. So here zinc will be obtained in the form of sulfide, ZnS, zinc sulfide. So what will happen here? It is in the form of sulfide ore. We have to convert sulfide ore into oxide ore in the presence of oxygen. We have to eat in the presence of oxygen. That is zinc sulfide. Now we will get a ZnO. So this ZnO, what we are doing is here, roasting we are doing here in the presence of oxygen. After getting zinc oxide, we have to eat that to convert the carbonate ores and changed into oxides by eating strongly with the limited air. That is called calcination. So here one process we are using by roasting, one process we are using by sulfide ores are converted into oxides by heating strongly in the presence of excess of air, that is roasting. So if we use this to change that carbonate ores into again oxide ores. So ZnO means here moderate reactive elements, it will be obtained in the form of sulfide ores and carbonate ores. What will happen to remove the sulfur? To convert this into oxide ores, we have to use heat in the presence of excess of oxygen, that is called roasting. So here what we have to do, carbonate ores we have to convert that into oxide ores in the limited supply of oxygen, or maybe with no, there is no oxygen. That is called calcination. Here to remove what is calcination and what is roasting is very important. To calcination is the process of converting the carbonate ores into a oxides by heating limited air or absence of air is called calcination. These two you have to do. First you have to convert the ores, that is carbonate ores and sulfide ores, into oxide ores. Then as usual what we are doing is that reducing agents we have to use. So metal oxides then reduced to corresponding metals by using a reducing agent. So here we are using a carbon as a reducing agent. When this zinc oxide reacts with this, what will happen? Carbon here we are using as a reducing agent. It will reduce. Then we are getting a zinc. So to get pure form of zinc, again we have to do refining process. So here we know already oxidation and reduction in the first chapter. So removal of oxygen by using reducing agents. That we have to do here. Why we should use reducing agents? One question they may ask. Then what is roasting and what is calcination? Here low reactivity, there is using roasting. Here moderately reactive elements, it will be obtained in sulfide and carbonate forms of ores. So we have to convert that sulfide ores into oxide ores by using excess of air. Here carbonates ores will be converted into the limited supply of oxygen or limited supply of air. So how these will be? We know that. So using reducing agents, we are removing the oxygen and we are getting a pure metal. So these, to reduce these metal oxide to metal, what we have to do? We have to do again displacement reactions also we can use. Instead of using coke, we have to use displacement reactions, means we have to use more reactive elements to remove the less reactive elements. So here one example we can take MnO2. You have to use more reactive than manganese. Aluminium is more reactive than manganese. What will happen? To get this metal, to get manganese, what we are doing here is high reactive elements we are adding. So when high reactive metals if we add, it will displace us the less reactive element. We are getting manganese is a metal. Then Al2O3 plus excess of heat will be liberated here. So here we are not using, we use reducing agents as a high reactive elements, and also displacement reaction can also be used here, because this can displace us. Here you will get a metal, so it is the oxide form of ore, MnO2. Here to remove the oxygen, what we need to do, more reactive metal if we add here, if we take as a reducing agent, it will displace as a less reducing agent. So one more, it is this displacement reactions will be highly exothermic. So there is a more and more amount of, large amount of heat will be produced in this displacement reaction. One example here we can take. iron oxide. So if you take a aluminium, it is more reactive. We are using aluminium as a reducing agent here. This aluminium replaces a iron. So we are getting a iron separately and Al2O3. Then excess of large amount of heat is released here. So the reaction of iron oxide with aluminium is used to join the railway tracks or cracked mission parts. So this reaction is called Thermit reaction. This is very important. What is Thermit reaction is? So while doing the displacement reaction or when iron oxide, in the iron oxide to remove the oxygen we are using aluminium, that time what will happen here? Excess of heat will be liberated. So railway tracks, this here if you observe the picture, here there is a one instrument. In this what is they are using? Iron oxide and aluminium. So here it we have. So this experiment is why we are using, this is very important. So Fe2O3 and aluminium we are using in this instrument. When these two are going to react, what we are getting? Excess of heat, large amount of heat will be liberated. Here you will get the large amount of heat, it will be liberates here. What will happen? This railway tracks are cracked missions. What we have railway tracks here, it needs more heat to melt. So that here this process it will be used to join this railway tracks. So where it will be broken, where it will be damaged, it will happen for the railway tracks. So it requires a, it is not easy to join this railway tracks that is made of iron. So that what will happen? So when it breaks, so we need to weld that. So normal heat, it is not enough to join these tracks. So what will happen? What they will do is they will use iron oxide. In that they will add aluminium. So as a reducing agents, while reacting these, when aluminium is going to remove the iron, what will happen? There is a excess of heat, large amount of heat will be liberated here. Then it start melt and it will get attached. This process is called thermit reaction. Here they will ask why will use this reaction. You should write the thermit reaction. If they ask, you write iron oxide reacts with aluminium, you will get iron. Then aluminium oxide and excess of heat will be released. So why we are using this reaction for weld the railway tracks means here there is a more large amount of heat will be released. So we use to join the railway tracks. That is, it will liberate a more heat. This will be very important. So next class, only small topics we have that we will study in the next class. That is extraction of metals with the top reactive metals, highly reactive metals, and one more thing, corrosion we have that we will study. Thank you for watching. Please like, share and subscribe my channel.